So if you're a computer vision fan, you'd solve problems like segmenting a picture like this into land and sky, right? It's a basic thing. You can download software to go and do that. And today's lecture is essentially going to be about labels such as that. And I do have some music for you, but I wanted to introduce it. There's clouds, so the music's from a film called Cloud Atlas, and this piece is called All Boundaries Are Conventions. So think about the picture and the music as a warm-up. So like lots of things, when you look closer, it gets fuzzy, right? So it's not clear, is this sky or land, right? There's obviously a mirage effect. So I don't know what some neural network would make of that, but no, the point is, it's illustrating the gist of today's lecture, which is all about putting things into categories and the significance of that for the kind of questions that we've been thinking about. I'll talk more about the title, which is a slight joke, later on. But to start with, something entertaining for you. So there's plenty of strange books being written in the world. This has probably got to be one of the strangest ones ever, by John Wilkins, Doctor of Divinity, Dean of Ripon, published in 1668. And his idea was people got confused about things because they had the wrong language. And so the solution is to come up with a better language. So he did that, and it is batshit crazy, right? I mean, you can look at this and see what you can make of it. Here he's spelt out the Lord's Prayer somewhere. But the crucial thing that he tried to do was to find, the one true way of categorizing things. That's what it was all about, right? We just hadn't put things into the right categories. Anyway, this bizarre book, which I think I put a copy in the shared resources, but if I didn't, I can share it with you if you want to look at it, was the inspiration of a wonderful short story by this Argentinian writer, Jorge Luis Borges, who we met, remember, a couple of lectures ago, the short story, The Lottery in Babylon. So he wrote this short thing. It's only a couple of pages long. There's some links there in the slides. You can just read it online, called The Analytical Language of John Wilkins. And this is quite a famous piece. Many people have quoted this because it's so crazy, right? So he says, you know, he came across this certain Chinese dictionary entitled The Celestial Emporium of Benevolent Knowledge. And in its pages, it is written that all animals can be divided into this category, into this taxonomy. Those belonging to the emperor, those that are embalmed, those that are tame, pigs, sirens, imaginary animals, wild dogs, those included in this classification. You know, it's a nice reflexivity there. Those that are crazy acting, those that are uncountable, those painted with the finest brush made of camel hair, miscellaneous, it's good to have that one in there, those which have just broken a vase, and those which from a distance look like flies. It's clearly crazy, right? But what's interesting about drawing this to your attention is, well, there's someone's demented categorization scheme. Who's to say that ours aren't similarly crazy? Or maybe not quite so crazy. The point about it is its sheer arbitrariness. Anyway, as I said, much has been made of this. It's kind of funny. I encourage you to read the short story. It's very entertaining. Well, that's fine in the world of fiction, but what about real categorizations, right? I mean, we're not doing this just to write funny stories. You know, how do people actually go, you know, surely no one in their right mind actually has categories like that. Well, there's a tribe of native Australians called Aborigines living in North Queensland, the Yerbal tribe, whose language has a taxonomic system where every object that you ever talk about, so by the way, this is a strange tribe. One of their conventions is that a husband is not allowed to talk ever to his mother-in-law and vice versa. That's one of the rules. Anyway, they've also got this taxonomy, right? So the first one is Bai, men, kangaroos, most snakes, some birds. I mean, Balan, woman, echidnas, the hairy Mary grub. This is a grub which, if you touch it, it stings, right? It's a nasty sort of thing. Anything to do with fire. All edible fruit and plants. And then the last one, bodies of the meat bees and so on. Anyway, so this fellow, George Lakoff, is a linguist. He came across the original work by Dixon on this, and it inspired him to write a whole book on how we categorize. And the title's quite famous. It's Women, Fire, and Dangerous Things, right? There's a category. This tribe has a category, and in that category they put women, fire, and dangerous things, right? It's inspirational, right? There's even a rock band that took inspiration from this, right? So again, this is not made up. This is real. Okay, it's a remote and detached tribe. Surely we don't do anything so crazy. So in Lakoff's book, his whole book is about what categories reveal about the mind. We can't think about things without putting them into categories. That's actually why it's hard to think about this topic, because we do it so easily and so often. We do it without thinking. So as he says, categorization is not a matter to be taken lightly. There's nothing more basic than categorization to our thought, perception, action, and speech. Every time we see something, we categorize it. And whenever we reason about things, we are employing categories. We can't avoid it, right? I'm not saying it's a bad thing. We have to do it, but it's a good idea to try and be aware of it. And we can, to use fancier language, and I'll come back to this later on, say that these classifications, they are a theory. They're a theory of how we in our minds think about the world, right? And that's what machine learning does, right? It builds models. Models are theories, right? Machine learning requires labels, categories, in order to make its predictions and do its work. That's why we're interested in it. So let's be more specific about our problem. By the way, I didn't say where we were today. So this is a place in Australia called Lake Mungo. I'll come back to that later on. It's in the far outback. 60,000 years ago, when the sea levels were higher, this was a a lake, a giant lake. Now it's incredibly dry, and the only thing are kangaroos. You'll see lots of kangaroos. So what's our specific problem? Machine learning, and especially the machine learning that has social impact that we're interested in, makes use of labels, in particular labels about people, right? The questions that we were looking at with fairness at the beginning of the course, we had these protected attributes. Attributes are labels. Attributes are names that we give to these labels, such as race, sex, personality type, customer segment. Some of these categorical distinctions are singled out to be protected, and they're the focus of fair machine learning, group-based fairness in particular. And my main takeaway from today's lecture is something I've already hinted at earlier in the course, is that this choice of attribute, the choice of the categorization that you choose to protect, is far more fundamental and important than any particular choice of the objective function or the algorithm used to control the statistics. When you go and look at the literature on fair machine learning, people will argue the toss about different measures of fairness, different algorithms that they'll go and work with, but it's quite rare indeed to see anyone thinking hard about, well, why are we protecting on sex, or why are we protecting on race, or some other thing, right? So today we're going to try and figure out how to even think about that. Many of these labels are not taken to be inventions of our mind, but properties of the world. I'll come back to this later on. So there's a phrase in philosophy, they're called a natural kind, right? That it's not something in my mind that I'm categorizing the world this way. The world really is in these categories. That's the premise. And I hinted at the beginning about, computer vision tasks. There are these benchmark problems that people pursue called the object recognition challenges. And they will go and present thousands, hundreds of thousands of images accompanied by, in the training set, the correct class label. This is a chair. This is a monkey, right? This is a wristwatch. So those things are labels. And much of the time this works well, right? Sometimes it's not. So specifically, what am I interested in today? Where do these categories come from? What's their basis? What's the basis for privileging some of them and not others? And we'll examine these questions from a few perspectives, a bit of philosophy, psychology, sociology, and very, very briefly, political. And this sounds like a rather simple problem. How on earth can you make a single lecture out of this question? I had the most enormous trouble fitting it into a single lecture. It's intriguingly complicated. Hence, there's a big long list of papers that you might have seen on the in the Moodle site. So people have been grappling with this. It's not just, antique philosophers or Argentinian novelists or Berkeley linguists who've thought about it. There are people who, make this the sociological consequences of classification their key study. And by far the standout book on this, which I think you can get through the university library online, is this one here, Sorting Things Out, Classification and Its Consequences by Bowker and Starr. So these two people are sociologists. This is a fascinating book, I found. I read this a long, long time ago. The picture, by the way, so these are the kind of bracelet you get when you're in hospital. And one of the chapters in the book, they analyse many of the consequences of a thing called the International Classification of Diseases. So this is a big bureaucratic thing that all the hospitals around the world will work with. If you have some disease, you look it up in this giant book and you get a code number, right? It's a way, it's a way of having a common name for things, right? There is this nasty disease called diphtheria. It's in there, right? You know what it is. This person's got a heart attack, right? So it's this giant, it's an enormously big book. And what's intriguing about their study is that they don't take this for granted. They go and look at what the consequences of it are, right? You just have to, it's not hard to think about this, right? For insurance, maybe insurance doesn't cover you under certain categories, right? Or maybe the costs are different. It's not hard to think of why this would matter. Okay. So the philosophical warm-up, second kangaroo, should have got you to spot the kangaroos. There's quite a few of them. So For those who'd never heard the phrase categorical imperative, it's a minor joke I'm making. It's a very famous maxim due to Kant, where he tried to distill all of ethics down to a single phrase. Right? Good for him. Right? And like, here's one. He actually had several versions of it. They're all completely different. This is the most well-known one. Act only according to that maxim whereby you can at the same time will that it should become a universal law. This is the guy, by the way, who said that it's such a bad idea to tell a lie that if a murderer knocks on your door looking for your friend, you should tell the murderer where the friend is because it's bad to lie. So much for deriving your morality from some single principle. But of course, I mean something completely different by the phrase, simply the imperative that we have to categorize things. By the way, it's called categorical in contrast to hypothetical, and if that interests you, there's a link there, but we don't really need to worry about that. I do think actually understanding our categorical imperative is relevant to his perspective, but I'm not going to really dive into that. So only for those of you who are interested in this stuff, you can follow that up. So another place you might think categorization, sorry, let me restart that sentence. So machine learning does rely on philosophy a lot, although sometimes it's rather hidden. One common bit of philosophy that's kind of folk wisdom in the machine learning community is Occam's razor. Anyone not heard of Occam's razor? You've all heard of it. You probably misunderstood it because everyone seems to misunderstand it. So this is the usual thing, he doesn't want anything too complicated, right? So he chooses a simpler model. But that's not what he was actually interested in. What he was interested in was something much closer to the topic of today's lecture, and it's what they called the problem of universals. So it was like, chairs don't really work here because they're all mirror images of each other, but that's a computer, that's a computer, that's a computer, that's a computer. What's common about computers? Is there an actual thing, right? You have this abstract class. So that's what he was thinking about. And this fellow, Alain des Rossiers, who I've talked about before in The Politics of Large Numbers, he actually makes this explicit. I'm going to quote him here, where it comes down to a question of the realism of aggregates. So it's the distinction between here, your individual people, right? And that's kind of clear. But I can go and put you into an aggregate, right? The class of students who I am now teaching. And the question is, in what sense does that entity exist? Right? It's an abstraction, right? I can't pick up the class. I can't hold the class liable. The class itself can't do anything. All those things are down at the individual level. So that's his point here, right? So this is what des Rossiers says. One argument against postulating abstract objects is based on Occam's razor. According to this principle, one should not multiply entities or kinds of entities unnecessarily. That's what he meant. Entities should be not multiplied beyond necessity. Don't go creating abstractions when you don't have to. There's nothing about choosing a simpler neural network. Thus, if one can show that certain concrete objects can perform the theoretical roles usually associated with the abstract objects, one should refrain from postulating abstract objects. That's Occam's actual razor. And so he was adamantly what's called a categorical nominalist. He didn't believe that these categories actually existed. They're just made up in our heads. The opposite position is called categorical realism. As usual, these names are confusing. Like you'd think, surely categorical realism is the more realistic position to take. It's not. It's the opposite. Right, so that's what I said here. And it's interesting, des Rossiers talks about the concrete example of this, that the Catholic Church wanted to return a monastery to the Franciscan order. The Franciscan order was a collection of monks. And Occam argued against this. I guess they didn't want all of the obligations that went with it. And his argument was, you, the church, can't give the monastery to the Franciscan order because the Franciscan order is not an entity. How can you give something to something that's not an entity? It's an abstraction. This philosophical problem was solved by the merchants in England when they invented the joint stock company, right? If you think about, that's the whole idea of a modern corporation. The modern corporation solves the problem of universals. So Occam was in good historical company. You recognize this guy? Yep. So Karl Marx says, what is to be avoided above all is the re-establishing of society as an abstraction vis-a-vis the individual. That's weird language, but his point was he didn't want to go worrying about, oh, we have to solve the problems of society. Society is an abstraction. There's people. People can suffer harm or do well. He didn't want to go and put all of our efforts worrying about society because that's an abstraction. And he wasn't the only one, right? So if you look closely at his face, right, you'll see it's actually very similar to someone else's face, right? Margaret Thatcher said the same thing. She's 100% lockstep with Karl Marx. Who would have thought? There's no such thing as society. There's a living tapestry of men, women, and people. And she goes on to say, society as such does not exist except as a concept, right? They're both methodological individualists, right? They both are focusing on the individual people and being wary about what the abstraction is. So that's all good fun, but we're interested in actually using machine learning to do stuff. Machine learning is just fancy statistics, essentially. John Venn, who was a scholar at Cambridge in the 19th century, he wrote probably one of the first books on the philosophy of statistics called The Logic of Chance. And he observes that you can't do statistics without groups, right? And so what he specifically says is the regularity we trace in nature is owing, much more than is often suspected, to the arrangement of things in natural kinds, each of them containing a large number of individuals, right? You can do statistics about horses. That presupposes a notion of a horse, right? He goes on, a large number of objects in the class, together with that general similarity which entitles the objects to be fairly comprised in one class, seem to be important conditions for the application of the theory of probability to any phenomenon. So look at this. You're putting things into classes and you're appealing to similarity. Group-based fairness, individual fairness, right? Goes back to the 19th century. And I think it's important to recognize that, this concern about categorization, it doesn't just crop up when you're worried about ethical concerns. It crops up whenever you want to do any statistics at all. Recall from a previous lecture I talked about the reference class problem, which is the same thing essentially, right? It's what categories do you put things in when you go and do your counting. So other people said the same thing. Gabriel Tarde was a French sociologist, I guess, but he wrote about sort of the basis of statistics as follows. Statistics is an enumeration of acts which are as much alike as possible. Here the art is in the choice of the units. The more alike and equal they are, the better they are. Essentially what he's saying is that you've got to go and put things into categories. If the categories are good categories, in the sense that every element within the category is really very similar to each other, then that's better. If I just sort of segmented the class into the people in the front and the people in the back, maybe I don't learn so much, right? If I segmented into those that were born in Europe and those that were not, maybe I'll learn something. Right, I don't need to say the rest of the stuff there. And I think this is the final bit of philosophy. This is William Van Ormond Quine, a famous American philosopher. He's talking about the notion of a natural kind. So this is a bit of jargon in philosophy due to John Venn, who we just saw before. And the idea is that, yes, sure, you can go and put things into groups, right? But there are some groups that are natural. Like if I think of all the animals on the farm, there's the cows, there's the horses, there's the chickens. These are natural kinds. They're biological species for sure, but they have this notion, a natural kind is one that it's just natural to put things into. he was trying to figure out what on earth a kind could be, and he observes two things. Kinds can be seen as sets determined by its members. It's just that not all sets are kinds. That's essentially what I said before. And then he goes on to observe, so I observe that the two broader, I said this before, group fairness corresponds to kind and individual fairness relies upon similarity. But then, this is the interesting thing. He goes on to say, in general, we can take it as a very special mark of the maturity of a branch of science that it no longer needs an irreducible notion of similarity in kind. What he's saying is that, yes, to start to understand the world, we put things into groups. We think in terms of similarity. It's the first way we start making sense of things. Little kids can do this perfectly well, but that's the beginning of a science, not the end of it. And if I remember what comes next, Alfred North Whitehead said the same thing. So he's arguing that classification is a halfway house to the complete abstraction of a proper mathematical notion. Unless you can progress from classification to mathematics, your reasoning will not take you very far. A civilization which cannot burst through its current abstractions is doomed to sterility after a very limited period of progress. So he's arguing that these categories that we use in all of our reasoning, they're a good starting point, but we shouldn't think of them as the end point. So this gives us a good motivation. Here we are with machine learning. We use the true class label all the time. There's all these benchmark problems that have all of that. But with that, we inherit all sorts of ethical headaches that we have to go and deal with. Here's a hint of a potential solution. Don't try and find better labels. Don't try and find better algorithms. Don't try and find better objective functions. Try and transcend the use of the labels in the first place. So one way you could do that, this is Alain Desrosiers again, is just thinking in a kind of formal mathematical way. Don't think of your categorization as just a petition. Right? So you can think of, I'm making a petition of the world. You think of a richer combinatorial structure. So he talks about categories as networks. If you start thinking what makes your categories, it's always you're starting to compare things to others. And you can just go and do that pairwise, or you can have a much more complicated story. Just try and think, if you wanted to if you're using a particular taxonomy, try and explain where the taxonomy came from. That alone, right, even if it's not entirely correct, at least it's better in a sense than just saying, here's my taxonomy, take it or leave it. Right? Because if you've just got, here's my taxonomy, take it or leave it, there's nothing anyone can criticize. And if you've already gone and put all of your data into those categories, you've lost all of the subtleties. Anyway, we'll come back to that later on. Another attempt where someone has tried to go beyond that simple notion of categorization, rather than just thinking of, it's thing-like, you think of it as a relation. So this was written some time ago, I think in the 1940s or something. He has this interesting example that is a good segue to the psychological stuff we'll be talking about shortly. So he talks about it may be wrong to state that the blonde women, so that the set of all women in a town who have blonde hair, the blonde women living in a town exist as a group in the sense of being a dynamic whole which is characterized by a close interdependence of their members. So here he's using the word group in a different way. And I'm going to introduce a sharper terminology shortly to keep this in mind. I can just say the set of blonde women. It's just the set of people who are a woman with blonde hair. Or I can go and talk about the group of blonde women. Maybe they all walk their dogs together, right? Or maybe they all get together and talk about blonde hair issues. Who knows? His point is that, in the stuff here in yellow, if, however, the blonde members of a workshop are made an artificial minority, let's suppose everybody in town says, we don't like those blonde women, right? If you're a blonde woman, you have to live on the other side of the river or whatever. So, if they're discriminated against by their colleagues, they may well become a group. Now they become an action group. Now they start writing letters to the newspaper. Now they start doing protests, right? You've made them into a social group with an interaction. So there's this distinction between it's just a set and it's a group in that stronger sense, right? You know, it's like a group of hobbyists or what have you. I think I'll skip the last bit. So, I said at the beginning that, you know, we can think of categories as theories. So, what other theories might there be? So we already know this from like the technical machine learning you would have already learned about, right? So you can use categorical labels, or you can have class probability estimation. We can have a scoring function. So I don't go and say that, you know, you're German. I say there's a 0.9 score, right? Because maybe your great grandfather was French, right? I don't have to solve the problem of making it either or, right? I can work with a continuum, and maybe for many problems that suffices. So this is an easy way to sidestep the problem of categories. So there's some pointers there. I think that's all I wanted to say about that. Another thing that we think might be helpful for us is we go and ask, we say, we're trying to understand the significance of categories and classification for what we do. Why don't we have a look at what people who really know what they're doing do, right? And so you go and look at systematic biologists. You've got the Linnaean taxonomy. You put all of these species, you know, all the animals have a species, right? And what a species is crystal clear. You know, we can always tell whether one animal's in this species or not, so why don't we pay attention to what they do? Well, here's the thing. It's not actually so clear after all, as it turns out. Not only is it problematic in many cases to work out whether one animal is in this species or the other, there are raging debates about what a species actually is. So you'll have biologists who hold completely different notions of this. This is an entire book on the very notion of species, right? Different concepts of species. So it's at a meta level, but it's kind of surprising that there's actually so much literature, and it ends up really mattering, right? And you can kind of imagine how this matters. So think of something even more fine-grained like race. We'll get to that later on. We take it for granted that we know what race is. We use it as a label. We make it a protected attribute. But do we know what it is? Well, we don't even know what a species is, right? Ernst Mayr, who's one of the most famous evolutionary biologists of the 20th century, he was very wary of leaning on species. So this first up is quite surprising, right? You would think, you know, Darwin writes this book, The Origin of Species. Now you've got all of these evolutionary biologists. Surely what they do is they study species, right? No. So he's actually pushing back on the idea that it's helpful. And instead he says, well, he talks of it, the distinction he makes is typological thinking versus population thinking. Typological thinking is where you say there is a type. There is this species. And then we go and reason with that species, right? In other words, we reason with the category label. What he would call population thinking is, no, there's a group. I have a distribution. The boundaries are fuzzy. And I go and reason with the distribution. Reasoning with the distribution ends up giving you much better biological knowledge than reasoning with the species. That's the interesting fact of the matter, right? You can read his 1,000-page book to learn more about it, but that's the gist of it. And you know, this distinction, we're going to keep coming back to it, and I'd already introduced this to you quite some lectures ago. This Belgian astronomer Adolphe Quetelet, he had some great insights. He realized that you could learn a lot of stuff just by doing statistics, but he genuinely thought that what he called a type, what we would call a category, he thought they were real things, right? He was interested in the difference between Belgians and French people, for example. And he says, no, there's this difference. And his job as a, proto-sociologist was to go and figure that out. And then when he saw that there was variation, so intra-class variation, he would just say, oh, that's just error, right? You know, there's the Belgians and there's the French, but our measurements aren't that accurate, and so that's why we go and see the distribution. Now, the other way of looking at it is, no, actually it's a continuum. Yes, maybe there's some factors that make some French people more like this and some Belgians more like that, but it's not a categorical thing. It's diametrically opposed viewpoints. And what's surprising is that this paper, A Mean and Random Pass, The Implications of Variance for History, they claim that most writers in social science methodology still emphasize errors in measurement as the principal source of this phenomenon. Yep?
And isn't it also the case that once we put labels in place, maybe the groups become different over time because they get treated differently?
Yes, we'll get to that. Yes, yep, exactly. So all of what I've shown you so far is pretty antique stuff. This lady's contemporary. She's a professor of sociology at Berkeley, and there's two papers that she's written that I've pointed you to. One of them is Categories All the Way Down. So she's alluding to there's a silly story about some woman going up to Bertrand Russell after he gave a lecture, and he'd been talking about the structure of the universe, and she comes up to him and says, Mr. Russell, you're completely wrong. You know, the universe sits on the back of a giant turtle. And Russell says, but what does the turtle sit on? And she says, not so fast. It's turtles all the way down. It's just like turtles all the way down. So that's, when she says categories all the way down, that's what she's alluding to. It's nothing to actually do with turtles. But I'm encouraging you to read this, so I won't go and read out the quotation there, but she's, I guess, the leading contemporary scholar who's trying to understand classification, what she calls ordinalization. When she says ordinalization, that's essentially ranking, right? So you can put people into categories, or you can put them into ranks, or you can assign scores. There's at least three mathematical things that you can go and do. And she's interested in the consequences of that mathematization of people. I encourage you to go and look at that. So the two papers, Categories All the Way Down and Ordinalization. So, I'm going faster than I thought. We have a break. All right, we carry on. So that was also from the film. I really encourage, if you like interesting novels, the novel that the film was based upon, Cloud Atlas, for computer scientists has got an interesting structure because, so if you've ever met a book that's got a story within a story, so this one has a story within 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 a story. And as the book goes, you dive deeper and deeper in. And in the middle of the book, you start popping the stack, right? And you go back again. And only when you get to the final bit. And then the whole thing coheres. And then it was made into a film by the Wachowski brothers. But they, instead of doing that nested structure, it's all just tangled up. So you end up with these like 6 stories running in parallel. But they all interact with each other. And they use the same actors in different roles for the different stories. And the actors change sex as well, really to mess with you. So anyway, it's a wonderful experience. Cloud Atlas. Cloud Atlas. David Mitchell wrote the book, and the Wachowski brothers did who are now the Wachowski sisters. Maybe this was what they did the movie. All right, so where do categories come from? We make them up, and we seem to be hardwired to not just make these up, but once we've made them up, to give them reality beyond which they deserve. So this guy, Henry Tajfel, I think he was Belgian, sociologist, he wrote, I guess it was in the late 50s or 60s, he developed this thing called the minimal group paradigm. And just to give you a flavour of this, he would do experiments where he'd just get a bunch of students probably, and he'd randomly assign them into 2 groups. Just, randomise. You're in group A, you're group B, you're group A. Moves them aside to each other, and then he says, okay, group A people, I'm going to give you a name, Klee, Paul Klee, modern French painter. You guys over here, you're Kandinsky, some Polish painter, right? That's it. I'm just giving you the labels. So think about this for a while, do your group bonding or what have you. And then he put them together in some social decision tasks where, there were certain things that had to be allocated. Now, every person, every subject knew that these categories that they were put into were completely arbitrary. It was very transparent. I'm just going to arbitrarily do this to you, right? But now you're in the Kandinsky group. And what happens? Well, you start fighting hard for the Kandinskys, right? So when you see someone from the Klee group's going to get a prize, it's nothing to do with you, but you've got a fellow Kandinsky member, you fight for that, right? And what he was interested in is, that's why he calls it the minimal group paradigm. How little grouping do you have to do in order that people start behaving in this fashion? And the answer is astonishingly little, right? You're completely arbitrary things. People will act as if we're real. So, I've written, we're like category amplifiers. As soon as we get a sense that, oh, I'm in this group and you're in that group, I have this in-group bias. People have now studied the way children learn to do this. Like when you go and, you send your children to kindergarten in order that they learn socialization, part of learning socialization is learning this fact, right? Learning how to put people into categories, insiders versus outsiders. So the paper's Group and Moral Boundaries, Developmental Perspective, Making Race Out of Nothing, Psychologically Constructed Social Roles. So this partially speaks to the question you raised, where these things come from. You start with a whiff, and then it just feeds back upon itself. So here's the irony. This is what we do, right? Over and over, this stuff has been corroborated many times. It definitely happens. We do it all of the time, but we hate it when others do it to us, right? Who says that people have to be consistent? So this is Abraham Maslow, famous psychologist, and I've put a section of a book he wrote. It's only a few pages long, and the chapter title is called Resistance to Being Rubricized. So the word, he uses this word in a funny way, but what he means by it is if I just treat you as a category, right? So you look like you have Asian parentage, right? If I just said, oh, you're Asian, therefore da 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 da, you'll be pissed off, right? Everyone gets pissed off by doing this. So you've got this weird, dissonance, right? We do this all the time. We put people into categories, but we hate it when others treat us as if we're a member of a category. So, I'm sure you've all had experience of this. And then, reflect on what machine learning algorithms are doing, right? They too are going to be category amplifiers. If you go and say, well, we go and train our algorithm, we've got this data set, we can't afford to get the data ourselves, we'll just use the labels that they've already got, we go and build our predictive model, great, we can now go and do stuff. What have you done? You've reinforced that particular categorization. Now, this might be a fine thing to do, right? All I'm flagging is that it could cause harm in the same way that the examples that I just mentioned here do. Now, so, children learn to do this, and I said it's kind of hardwired in us, and some people have tried to study like the developmental psychology of how we learn to put things into categories, and I think this is quite interesting. So Eleanor Roche got quite famous for it's one of these observations that, kind of anyone could have made, but she's the one who made it and then went and developed it. And she observed that if you pay attention to the words that we use for certain things, right? So chair, table, they're short words, right? They're the sorts of words that a young child learns early on, right? A 2-year-old, when they're learning language, these are the simple words that they start to learn, right? They don't learn so easily abstract things like furniture, right? A 2-year-old's not going to say, Mummy, can I climb on the furniture, right? It's, can I climb on the table? And likewise, the 2-year-old's not going to be able to say, can I play on the modernist pressure-formed plywood desk chair, right? With all of those specific. So Roche's point is that you've got this middle ground, right, which she calls basic level categories, and then you've got the more abstract things and you've got more specific things. So it's not the case that we start at the bottom or at the top, but we start in the middle. That's the interesting thing, right? And it's reflected in all of our language. You look at what the short words, the premise is that short words are words that are widely used, they're concepts that are widely used, and so they're the ones that kids learn easily. And then she also, so from that observation, she then developed her theory of how we think about categories. And her key idea was the notion of a prototype. How do we decide that something is a chair? So we have a kind of a prototype chair. If you'd studied philosophy, you'd think of Plato's ideal chair, but this is a lot more kind of concrete. She's just thinking it's a representative example that you kind of have vaguely in the back of your mind, and then you just compare to it. Think of k-means, right? It's something in the center of in the cluster. But anyway, look, I mentioned this because we're talking about we build these AI technologies. Remember in the previous lecture I told them as intelligence amplification. They amplify our abilities. They're doing similar things to what we do. So therefore I think it is interesting to understand what's known about the way we build our categories ourselves. Now there's one moving towards the trickier question of why do we privilege some categories more than others? There's a notion that Donald Campbell came up with this word, and if you practice pronouncing it, you can say entitativity. It's got 4 T's. I've highlighted them all, right? It's a tricky word to say. So he was interested in what is it that makes an entity an entity. Entitativity is the property of being an entity, right? And recall the example I gave of the blonde woman. When they started to share a fate, everyone was picking on them, they became a group. So Campbell, he contrasted things like there's a bus stop out there, there's just a bunch of people waiting for the bus, right? That's a set. They're not really a group, right? It just happens to be the set of people. Now, if those people got on the bus and ended up in a ridiculous movie with Keanu Reeves about a guy who puts a bomb on a bus and then there's a hero got to come and rescue them, then they become a group, right? They're all in it together. They're the people on the bus in the film. There is a film. It's really stupid. The bus goes racing around Los Angeles. Yeah. But it's kind of funny. He didn't see the film because he wrote this in 1959, but he did give the example of the bus, right? And so I immediately thought of the film. Anyway, this is the paper that he wrote on this. Common fate, similarity, and other indices of the status of aggregates of persons as social entities. So, in less words, his key conclusion is the two things about a set of people that turn them into a social group are common fate and similarity. They share the same fate, or there's some really obvious similarity. So sex is one, right? We can just see this. We look at a person, we can usually tell what sex they are. So there's a notion of similarity there. So there's now actually a big literature on this about how people construct these groups. People look at the effects of increasing the diversity or the size of the group. I think this is interesting because, remember the way I posed the question, one of the questions at the beginning of the lecture is to say, fine, we have to work with groups. It doesn't seem like we can get around that. And when we go and talk about fairness, it seems very hard to get around talking about the groups either. But which groups? So this question of what we deem to be a socially significant group seems relevant to the question of what groups we should pay attention to if we want our machine learning algorithms to be ethically sound. That's my logic, right? So there's a lot of literature on this. This is a whole field now, social psychology, about these things. And some of these titles are kind of interesting, like I belong, therefore I exist. In-group identification, in-group entitativity, and in-group bias. So this is the looping effect that you talked about before. Your identity, you figuring out who you are as a person, that gets amplified by the groups that you consider that you're part of. So I think this is so what's behind this phenomenon that Campbell figured out. So one attempt at answering that was by this lady Susan Gelman, who talked about essentialism. So essentialism is the notion that categories are such because of their essence. There's something essentially different between men and women. There's something essentially different between people with black skin or white skin. It's not just some arbitrary thing, right? It's not like there's people that are over 170 centimeters tall and people below, right? There's nothing really essential there. But when the psychologists study the explanations people give to why they privilege certain categories, this is one of the reasons that are given. Now, this is not to say that this theorizing is correct, right? I don't believe in essences, but apparently folk psychology does. That's the takeaway message of this. And this, it doesn't really fit. This slide doesn't really hang together properly, but the essentialism idea is not really relevant to this other point that I want to make, though, and that is now specifically talking about the groups that we privilege when we worry about, ethical fairness or what have you. So the groups serve as moral boundaries, and children learn how to perceive these boundaries as part of the socialization. So that's what I was getting at before. This in-group and out-group, right? You have to look after your tribe, right? That's like, there's games you can download on your phone. Like there's one called Clash of Clans. I've never played it, right? I've seen an advertisement for it. And the tagline is, look after your clan, right? They're reinforcing this, right? That's the whole point of the game. Let's amplify in-group bias on the App Store. That's what it's all about. So that's what this paper talks about. Groups as moral boundaries, a developmental perspective. They look at the way little kids, I think they're like age 4 or 5, going to kindergarten, how they learn to be socialized, which means how they learned the correct in-group, out-group bias. Right? Okay. We met Sabina Leonelli in an earlier lecture. She's studied the philosophy of biology, and particularly she wrote this paper, Classificatory Theory in Biology. And I guess I'm just mentioning her to reinforce this point, the more abstract point I made earlier on, that classifications are theories. And, you can read what she's written here about, she's interested in actually doing science, but like the classification scheme that you work with affects the science that you end up with. So there's this literature, some of you are pursuing this for your assignment on, value ladenness. Do scientists make value judgments, or is science entirely value neutral? Well, putting things into categories often is a value judgment, right? Particularly if you think of the kind of categories that we worry about with fair machine learning. So there's some more pointers here. So this paper in particular, the first one, Ontological Choices and the Value-Free Ideal, it specifically talks about that very point, all right? So he says explicitly, he argues that the truth values of scientific statements depend upon these classificatory choices, and particularly entities such as species, race, intelligence, depression, obesity are true or false relative to the choice of a biological, psychological, or medical ontology, right? Let's pick obesity, right? So this is judged to be a disease, it's treated by the medical system, but how is it defined, right? This is an arbitrary category thing, right? People go and look at this thing called the body mass index. Someone does this stupid formula that looks at the weight divided by the square root of mass or something or other. I can't remember how it works. And if you're over this number, you're deemed to be unhealthy, right? It's a rather concrete way of defining a taxonomy according to a scoring rule. So why does all of this matter? I've already kind of alluded to this. We take these social categories for granted, but let's talk about the consequences of them. So just a little anecdote about, the photographs in today's lecture I said were Lake Mungo. So you can look this up if you're interested in. So there's a thing called Mungo Man. So why did I go to Lake Mungo? It's famous because of Mungo Man. And who was Mungo Man? Mungo Man is the remains of a human who lived 60,000 years ago, and it is the oldest known remains of a human with a culture. And the evidence is funerary rites, right? So the way his remains were buried. He didn't just die and decompose, he was buried, like there was artifacts or something or other. So, it's kind of like first civilized man or something or other. And so, of course, people in Australia think, yes, Australia had the first civilized person. Well, no, they have the oldest known remains, right? You observed how dry this place was, so things don't rot. So, well, anyway, it got found. But that's the backstory. The story that I want to tell that's linked here in the Wikipedia article, Lake Mungo Remains, is, okay, so these remains were found by some academics at the university that I used to be at, and scientifically this is interesting. Okay, understanding that, 60,000 years ago already people were doing these rituals, it gives some scientific insight into the development of higher culture. And then, so what do you do with the remains? They studied them, they did laboratory tests on them, and then they put them in the museum, right, to look after them on behalf of everyone. But then the Aborigines who live in a tribe that is now near there, they said, well, no. this fellow, he's part of our tribe. We should decide what happens to his remains, right? And this is important to our religion and so on. Now, my point is not whether or not it's legitimate for people to have a view like that. The interesting thing is, how do you decide which group of people this fellow sits in? He lived 60,000 years ago, and now we've got these different categories. So the big argument that you can go and read about was all terribly controversial, and in the end his remains were returned and they were buried back in the lake in a secret spot that no one knows apart from the local tribe. Okay? I mean, in the end it doesn't really matter because the scientific conclusions have already been drawn. They were studied, you don't actually need the bones anymore. But, you know, what I found interesting reading this story was, you know, how vehemently people held to the view, no, he's in this category. No, he's in this other category. These category labels, these category problems just crop up all of the time. Now, this was a question of which tribe he belonged to. The more broad category is the question of race. And we've mentioned this many times, right? So you go and read the papers in the machine learning literature about fair machine learning. It's one of the standard examples. Remember the first slide in the first lecture of the course, this was to do with race, right? What is race? I've avoided the question for now. So Alfred Kroeber was a very famous American anthropologist. And like if some of you want to become a famous scientist, you know, you might think about winning prizes or having a big H index or something. But Kroeber had a bigger impact than that. So you see he's got this beard. The way anthropologists judged Kroeber's impact was it turned out that, you know, after his fame was secured, most American male anthropologists had a beard like that. I think that's such a good story. I can't give you a source for that. I read that somewhere and I thought, this is so good, even if it's not true, I'm going to repeat it. But it's pretty cool beard, right? Anyway, but he was famous for a good reason. So he wrote this giant book called Anthropology, and the subtitle is Race, Language, Culture, Prehistory. So it was all about, he used to talk, in the book he talks about studying the races of mankind. He was interested in how different groups of people chose to live, all of their practices. I mean, the subject matter of anthropology, and you have to, you know, you need some word to use to describe the different groups of people, and the word that he uses is race. And then there's a big chunk of the book where he says, okay, this is what we want to do, but we've got this methodological problem we have to solve, which is, well, what do we mean by race? How do we work out whether, you know, you're in that race and you're in that race? And he goes through, there's this long list, you know, whether your hair is curly, right? So some people from Africa, the hair is flat and it goes curly. Color of the skin, the shape of the nose, all of these particular features. And he says, wow, every single one of these, you can find a really compelling counterexample to show that that's a dud. And so what's his conclusion? And this is what I think is so funny, is he says, and I don't actually quote him, but because his explanation is rather diffuse. So this is my distillation. He goes through all of these things and he says, none of them really work. So what I'm going to do is I'm going to take all of these things and essentially build a classifier on top of that. He made a feature vector. He took all of those features and then from that he built his taxonomy. It wasn't a single thing. It wasn't hair shape, it wasn't skin color or anything like that. So he categorized race exactly like a machine learning algorithm would. Take a big vector of features, then take some labels, right, where people would say, well, this guy's clearly such and such a pygmy, this guy's clearly South African, so and so. And then he goes and learns the taxonomy in that fashion. And, you know, since then, people have kind of come to realize this, that, well, maybe it's not such a clear-cut thing after all. Here's a paper, a post-genomic surprise, the molecular reinscription of race in science, law, and medicine. So when people started thinking hard about race, they didn't have the machinery of genetic analysis. Now we do. It just adds a lot more dimensions to the feature vector, right? But there are genetic signals, like people that would go and say, I'm in that race, I'm in this race. There will be genetic correlates, right? There is a genetic basis for things like whether your hair is curly, after all. So if you know the genome, you could predict the race, at least with some kind of accuracy. So the authors of this take this as a fact. You can't deny that. But then they get to the conclusion. This is the point they make. Out of all of the ways by which people differ from one another, why should it be assumed that sex and gender, race and ethnicity, and age are the attributes of identity that are most medically meaningful? So they were interested in, we want to go and personalize medicine in some way, right? So these medical interventions work on some people, they don't work on others. There's no reason to presuppose just because these things are salient to us, that they are entitative, that does not mean that they are the best for doing predictions. So that's one takeaway, right? I think these things, sometimes they might line up very well, the categories that we like to work with because of the way our brains think, but sometimes we might be better off using some other categories. There's some other literature. I mean, again, I don't really want to talk about this, but this is really just further developing the Mungo remains question. So this goes under the category of compensatory justice. So here you are now, and if you look back 5 generations ago, your great-great-great-grandfather and grandmother and so on suffered these injustices. You're fine now, but they suffered those injustices. The logic is, what recompense should be given to you now, right? These questions too, I mean, I'm not answering that question. That's a complicated question, but I'm simply pointing out that that question gets entangled with these categorical problems. All right, I think that's all I need to say about that. And I'm approaching the end, I think. There's an interesting connection. Do you remember, I think lecture 3 perhaps, we met the veil of ignorance with the song from the musical. So there's a nice story here about applying the veil of ignorance to category labels. So in Australia, there's a thing called the Australian National Disability Insurance Scheme. So this is a federally funded scheme whereby people with a disability, like a physical or mental disability, they can't look after themselves as well as everybody else, are essentially supported by the state. It was politically a big deal when it was introduced, I know, it must be nearly 10 years ago. It costs a lot of money. So everyone's tax went up a little bit to pay for this scheme, but I don't know. I mean, many people think it's wonderful. I think it's great. My daughter's looked after on this. She has a disability, so I think this is fine. Anyway, the point is, so this is the fellow who was in charge of designing the scheme, and he's talking about the point of how do you make such a scheme fair? And his point is, well, let's just read what he says. Certainty of support on the other side of Rawls's veil of ignorance, where none of us know whether we will become disabled ourselves or have a child or grandchild with a disability. So the point is, what he's using here is, you say, everyone has to pay, right? So this is a long-term thing, right? Maybe you're going to have kids in the future. You don't know whether they'll be unfortunate to have some disability. You pay now. Everyone pays now. And you then go and do the arithmetic. Only 1 in 50 people have the disability. And the money gets shared appropriately. But the key thing is, you didn't know the category label in advance, right? That's the point he's making. So it really, I mean, he uses, this was his words, right? He's explicitly appealing to the Rawlsian veil of ignorance. So this was in a speech that he gave, essentially arguing for the basis of the scheme. So I thought this was pretty interesting. So this is, Harvard philosopher writes this abstruse book on the theory of justice, and that ends up shaping, it must be hundreds of billions of dollars of investment over generations on the other side of the world. So who says philosophy doesn't have impact? Right. Another aspect of groups that we can't ignore is, people can be very strategic about this. So, you can go and say, I don't know, if you're a member of a particular group, you might argue that that particular group is the one that has to be looked after. It's as simple as that, right? You have a self-interest there. Now you're on the other side of the veil of ignorance. Once you know the groups that you're in, you're going to go and argue for, privileging that group. It's a very simple idea. So, it's got a nice simple name, strategic essentialism, right? It's saying that there are these essences, these are the ones that matter, but of course you're arguing out of self-interest. I don't think I need to say much about that. Once you get the idea that this can happen, I think that's enough insurance to avoid the trap, right? So if someone is a member of a particular group and they go and argue that that's the group that should be protected, how can you tell whether they're arguing strategically or not? The only way around it is to ask someone who's not in any of the groups. I don't see how else you can do it. So I'm just flagging this. I think this is a real problem. Like I said at the beginning of the course, I'm giving you more problems than answers. All of the problems that you have with groups, you can make a lot worse, right? If you want to. And one way of doing that is this notion of intersectionality. So it's a long-winded word for the idea that, well, you're not only black, but you're also poor and you're also a woman. Right? And there's various forms of this which would say those groups are hard done by in many countries. And the logic is that, not only are you hard done by for this reason, for that reason, and that reason, but you're additionally hard done by having all three of them together, right? So now the combinatorial structure of the groups gets a lot more complicated, right? So this is from a machine learning perspective. This is a real practical problem. You have a few thousand people in your data set. You can categorize them as having black skin or white skin, or male or female, or of this race or that race, right? Each of them is fine. And you've got enough data that you can make good predictors about each of them. Once you start intersecting all of those attributes, you end up with categories with hardly anybody in them, right? So I encountered this. I had one of my students in Canberra so we're interested in, could we predict the success of students at university better than the way it was done previously? So I don't know how it exactly works. Well, it's different in Germany because there's most university degrees you can just get into without some contest. So in Australia, there's this ranking that gets done, right? The schools do this complicated calculation on all your grades, reduce you to a single number, and then the universities say, we take everyone, from 100 down to 90. They get in. If you're below 90, too bad, you don't get in. That's how it's done. And the logic behind this scheme is that, lots of people want the fancy education, but we'll give the education to those who will derive the most benefit from it. That's a premise. And then the logical inference is that those who will derive the most benefit are those that have shown that they are good students. Now, you can argue the toss about that a lot, right? But the fact is that's the way it's done, right? We asked ourselves the question, we thought, we're hotshot machine learning people, surely we can do better than that. The way this scheme works is stupid, right? You just take all of the marks that people get in their high school, you do some simple formula, you spit out a number. We thought, no, we'll ingest big data, big rich feature of things. We'll take account of all sorts of stuff. We'll build a fancy model and we'll try and do better. We couldn't. So that lesson, by the way, is one that every machine learning person needs to learn. Often the simple things work very well. But then we wanted to understand, but maybe we can use this to understand issues of social equity better. So there are certain groups of people who want to go to this elite university. So the ANU is kind of one of the more elite universities in Australia. And so you think, here are these poor people from some country town, their parents didn't go to university. We want to make sure that they get a fair chance of it. So we start looking at all of these fairness constraints, right? And we start trying to build these models and so on. We did this, I think, on 10 years of data, every undergraduate student that was admitted. Once we started doing this intersectionality thing, we couldn't say anything, right? The numbers in the categories just ended up being too small, right? So we could just say, the confidence intervals were like this wide and, the differences were this big. There's nothing you could actually say. This whole research project only ended up with one insight, by the way, which we didn't expect in the slightest, which was that if you control for the score, so you control for the score of the students, and then you go and look at the difference in how the students went according to their sex. So this was a question people wondered, that, do the male or female students do better? In general, there was no signal at all, except in psychology, in which case there was this enormous advantage in favour of women. And everyone was stunned. The numbers were undeniable. So for what that's worth, I don't know. No one has a theory as to why that was. But that's all we learned from it. Anyway, intersectionality, it's a very fashionable thing. This big long quote you can read if you're interested in is from a slightly ranty book called Academia as Cargo Cult, written by a sociologist. Is one of these things like, you want to be, ethically sensitive and look out for social justice by paying attention to this category or the other. That's great. What if you do it for all categories? Surely that's better still. But the mechanical difficulties of doing this are immense. The Google Scholar results here, if you search for, what did I search for? Fair machine learning intersectionality. There's a lot of literature on this, right? But look, my point here is simply all of the problems that I've articulated about where the groups come from, that doesn't go away with doing this intersectionality. I think it just gets worse, right? So it's a thing, people are interested in it, but it doesn't solve the gnarly problems that I've been talking about. Now, another, it's related to what I'm talking about, but maybe it's not immediately apparent. Another use that people make of machine learning is making their systems personalized. You have personalized insurance, personalized medicine. We learn more and more about you. This is an interesting question to pose to yourself. You say, well, what does it even mean to make some treatment purely individual or entirely personalized? How on earth can I go and do that? Because if, the only logical way I can do that is to only pay attention to you. So I want to design some system personalized to you. The only way I can guarantee that it's only about you is to not ingest any data about anyone else, because it's only by comparing your data to everybody else's data that I can try and figure out something that's personalized to you. But now I'm doing the comparison, right? So you can't avoid these problems, these vexed problems of similarity and categorization. You can't sidestep them by just saying, I don't want to have to deal with all of that gnarly stuff. I'll just make it all individualized. Because this is what this point says here. You can't make an individualized prediction without doing some generalization, right? If I've only got data about you, I've got nothing to learn from, right? The whole way this magic works is that I learn patterns from other people and then use them to apply to you. But in doing that, right, I'm inheriting the prediction that I make for you must inherit all of the theoretical presumptions that I made in building my model, including the categorizations. So, yep.
Did this intersectionality approach work by looking at many specific categories, as in having like a large joint distribution, or as having some single labels, and then for one individual observing all of the single, categorizing it. I didn't explain this well.
I think I know where you're heading, but I can tell you.
It's like having looking at all the marginals and how everybody fares according to those.
Yeah, no, I understand what you're getting at. Look, when I said that, you know, our attempt to look at these questions didn't work, we were doing it in the most naive way possible. Simply, you know, we have 10,000 students, you know, 5,000 are women, 1,000 are women with this coloured skin, 1,000 are women with this coloured skin and you end up with just 10, right? Pretty soon you end up with a set of people that's extremely small, and it's so small that it doesn't make any sense to do statistics on. That's all that I meant. There is a more sophisticated approach to this problem along the lines that you described, which is very interesting, and this is actually something I'm studying myself at the moment. So, and I can talk to you about this later if you want. So this will just take a minute to explain. So normally, if we think of the way we formally set up probability theory, so now just talk about the mathematical theory of probability in the way the mathematicians like to do it. And they say that you have a sample space. It's just some big set omega, right? And then on that, you have an algebra of events. It's usually called a sigma algebra. It's got a particular property. Now, this is a set of sets. It's a collection of sets. And what makes it an algebra is that it's closed under arbitrary unions and intersections. So I've got my big set sigma, which itself is full of sets. I take any two sets, A and B, I take their intersection, A intersect B is also in the set. Likewise, A union B, likewise not A and not B, right? That's what makes an algebra. So pretty well all probability theory presumes that. Now think about what this means if we now want to apply probability theory to actual data, right? The set of measurable events is, by definition, the set of things to which you assign a probability, right? So if you have your algebra, and then here is an event and it's not in your algebra, mathematicians say that is a non-measurable set. There is no probability that I can assign to that. So what if, instead of your set system being an algebra, it had a weaker property, right? What if instead of saying arbitrary unions of events are in the algebra, in the set system, instead we say only that disjoint unions are in there. So if I have A and B and there's no overlap, then A union B is in there. Okay? So you can see that that's more restrictive. I don't allow arbitrary unions, I only allow disjoint unions. So in that case, you can model situations where, you know, these things have a probability and these things don't. And by appealing to De Morgan's theorem, the presumption that I made is equivalent to precluding arbitrary intersections. You can say, I've got my sets, but I don't presume, just because A is measurable and B is measurable, that A intersect B is measurable. But what you can do is you can say, all right, I can assign a probability to A, I can assign a probability to B, I cannot assign a probability to A intersect B, but what I can do is to give lower and upper bounds on the probability that it would make sense to assign to A intersect B. There's a kind of a consistency requirement that you can impose. So you can model this idea of not being able to get enough samples for these highly intersected classes by messing with what you declare to be a measurable set. So I know you can do that. Whether it ends up being useful, I don't know, right? But we've worked out the abstract mathematics of it, and it ends up having connections with a bunch of other interesting stuff. All right, I think I'm getting close to the end. So groups certainly matter. They matter for your personal identity. Amartya Sen reckons that it's one of the reasons why people end up fighting each other a lot, because, you know, you end up with fights between these two tribes or or nations or what have you. So if that interests you, you can read about that. I'm almost done. I wanted to look at how some of the, slightly unfairly, look at how some of the machine learning community deals with labels and categories and so on. So the first paper I point to, ConvNets and ImageNet Beyond Accuracy, Understanding Mistakes and Uncovering Biases. It's not obvious from the title what they're talking about, but the gist of it is what I've written there. You have your method, it kind of works okay. You make it look like your method works better by changing the labels, right? Hopefully it's obvious that this is a dodgy approach. Okay. I mean, this is like shooting fish in a barrel, by the way, trying to find machine learning papers that do something silly, but I'm only doing it on one slide. I did want to draw your attention to this other one though, which is, I don't know, this is a, what's the word? Make a good tabloid news story, I think. So there was 20 or 30 years ago, there was some people in Japan who were interested in the scientific question of the relationship between felt emotions and expressions, right? So if you want to understand people, you know, you can tell if someone's happy, if they're sad. There's many different emotions. You can categorize emotions in different ways. And so they wanted to understand, how is it, many people, not all of us, many people can look at someone's face and have a pretty good guess of how they're feeling because of the expression on their face. So they studied this systematically, right? And they ended up with a really large number of labeled data, labeled images, all these images of people expressing a particular emotion. And then the logic was you could then go and do analytics on this to go and figure stuff out. So they did this, and they made the data set available for research with very specific requirements. I mean, this data was all gathered in a legitimate way. You know, the people gave informed consent. It was done for research purposes. It wasn't going to be used for any other purpose, but they made it available to the scientific community. And so then Kate Crawford and this other guy, Trevor Paglen, came across this and made this huge story about it and used it as an example of how bad the machine learning community is, taking all of these images without people's permission and then using them for a completely different purpose. So this, if you've ever heard the phrase hoist by your own petard, they were complaining that the way they complained about doing this thing, they did exactly the thing that they were complaining about. They took this guy's images without his permission, used it in a way for their own purposes, right? And then when he asked them to stop, they just ranted at him on Twitter, saying how that he was trying to interfere with them. Anyway, I know Kate, and I read this and I thought, oh my God, talk about putting your foot into it. So, you know, she wrote this paper, Excavating AI, the Politics of Images in Machine Learning Training Sets. It was published in an academic journal. The guy who curated these images writes to the editor of the journal and says, look what they've done. They pulled the paper, right? They removed the images, they put the paper back in and replaced the images with text saying the editor demanded we remove the images. They never apologized. It's like, it's a bad story. I give this as an example of behavior that you should not mimic, right? And the poor fellow who did the original work, he went and he wrote about this, Excavating AI Re-Excavated, debunking a fallacious account of this data set. Anyway, the point is, it's very easy to throw stones, right? To say, oh, look at all these bad things that people do. It's actually pretty hard to be careful with this stuff. I think the fellow who did this was very careful, right? It was, you know, he used the images for only the purposes that they were used for. So, look, it's slightly off the topic of today's lecture, but I thought this was an interesting point to make. You might recall I did point to something from Kate a few lectures ago where she had this gigantic diagram of the genesis of an AI system, which is great, right? That's all good. But here she went and put her foot into it. Anyway, not everybody screws up. You guys won't screw up because I've told you all of the gazillion things that you have to be careful about. And I think this is my last slide. So, look, as I've said before, there's many, many ways things can go wrong, but I don't want you to misunderstand me as that I'm somehow making the point, oh, we should never use machine learning for these purposes. Because the fact is, as I've already pointed out in today's lecture, people are always going to categorize. Little kids learn to categorize. It's hardwired. We're going to go and do it anyway. Actually, this technology could help us do a better job of it if we take care about it. And the last specific point I want to make to answer the question that you asked earlier on, so Ian Hacking, this philosopher of science, he observed this phenomenon. He had a nice name for it. He called it looping. And the idea is that if I ascribe you to a category, you then internalize that category and start behaving in that way. It reinforces. It's performative. It's not just descriptive. It changes you. If I keep putting you into this category.
And also other people.
And other people, exactly. So you have this dynamic feedback loop where the categories get reinforced. And I think that can explain a lot of the anxiety about things like race. It's not like Alfred Kroeber just being the anthropologist dispassionately studying things. This ends up really mattering to people, right? Because of that reinforcing effect. So if you try to theorize about it without recognizing the feedback loop, you're kind of missing a large part of the story. So he's described this in this was written in just a newspaper article called Making Up People, where he talks about this with some nice examples. So I think that's worth being aware of. And as I've said before, the machine learning systems you can screw up in all sorts of different ways, but we should compare them to what we would do otherwise. We already use machines to categorize people and have consequential decisions upon them with bureaucracies. And so here's a couple of papers that look at the categorization that occurs using bureaucratic rules versus using algorithms, right? And tries to make a more of a balanced assessment. And my view is that if you should use all the technology at your disposal, but you should be aware of all the ways that it could cause harm. All right, so let me try and sum up this complicated mess of things that we've talked about today. Reason without classification is impossible. We have to classify. If we avoid the hard threshold of categorical thinking, that can potentially alleviate a lot of problems. And the good thing is many machine learning algorithms already do this under the hood. I mean, you think about how you typically build a classifier. You first predict a score and then you threshold it, right? And maybe you calibrate the score, right? In the sense that you try and make it a calibrated probability and then you threshold it. And we know how to drive the Bayes optimal classifier from that. But the point is, our technology works with scores anyway. It often only emits labels because we ask it to. The classifications and categories are not given by the world but chosen by us. That's an unqualified statement, but I think it's essentially true. And likewise, the social groups, which are central to the idea of fair machine learning, these groups are also chosen by us, and we should take that into account. And as I've already said, the choice of the groups that we deem sensitive is arguably more important than the fairness metrics or the algorithms. That said, there are some groups that are more group-like, and the notion of entitativity gives us a way of talking about that. We now have a word for that. Yes, it's true, we choose the groups. No, it's not true, they're all completely arbitrary. You can't go saying that my completely arbitrary random grouping is just as good as a grouping that everybody else believes in. If everybody else believes in it, it's probably because it's entitative, right? So we've got a language of that. These groups, they're important for our self-identity, so there's a plus side, it makes us who we are, but there's also a downside, right? In-group bias, out-group hostility, and so on. In principle, we could work with a much more sophisticated taxonomy and classification, right? We don't just have to have petitions, right? Notwithstanding what I said about the intersectionality, in principle, you could have a much more complicated story. Imagine, you've got your raw data, right? You can apply a particular set of categories to it and go and build your model. Or your friend could apply a different set of categories, or a different set. So rather than choosing the right categorization, in principle, you could work with all of them, right? That's something in principle we could do. I don't know anyone who's tried to do that. I'm trying to think of how to even start doing this. You end up with a mathematical structure that's more complicated, right? But in principle, I think this is, I think it's very interesting and it's very salient for what we're interested in. So that's the end of the second phase of our journey. Remember the architecture of the course, introducing fairness, all the sorts of problems. There's a sort of an interlude next week where Sebastian Zuzulka will talk about politics and power. And in the final two lectures, I will be constructive, right? And say, well, okay, given all of the complications that I've introduced to you, what is to be done? Okay.